Всем привет. Не ожидал, что это...
So, hello everyone. I didn't expect there will be so many people. And my presentation, who was at the after party yesterday? Great. Well, a report after party the next morning is quite challenging because sometimes speakers can miss them. I used to be at different conferences and sometimes this is the problem. On the other hand, the speaker has to collect his thoughts if the after party was successful for him. My after party was successful. So this is just another challenge for me. In order to be consistent and in order to follow the line. Well, as we're waiting for the presentation to start, I will just ask you a few questions. Are there any DBAs in the room? Okay, you are not my target audience. Any developers who work with databases? Okay, more of you. You are my target audience. Well, it's just better to say this beforehand so you don't get any regrets, because there are other interesting presentations, and I would attend both of them. I wouldn't attend mine because I already know it. Anyone for the first time at PGConf? Yeah, I see some of you. What do you think about this? How do you like it? Good or bad? Would you attend it once again? You can just shout. Don't be afraid. Don't be shy. Great. So I have some warm feeling for this conference because when I started to work with PG databases, after 3 or 4 months, I was told that in Moscow there would be the very first PG conference in Moscow. So I haven't missed a single one. All 6 conferences I have attended. First 3 conferences I used to be just a participant, and I was complaining that I couldn't attend all the sessions and there was no video stream. And next 3 years I was a speaker because I got some experience, I got some knowledge that I can share with you. And I recommend to you to do the same because all of us have their own experience. We do our mistakes, we do our solutions. That is why if you think whether to become a speaker or not, I recommend you to go for it. It will be a very big advantage for you. You will share some information, and if you do something wrong, good people will find you and say, you are doing the wrong thing. What if you try this or that? So such conferences are quite helpful both as you are a speaker or if you are a participant. If you are a speaker, you get even more advantages because people find you and they tell you what they think about you and your topic. So we can start. So I think we can get started because everyone who wanted to be here are here. So this is my official hello. My name is Andrey Salnikov. I am data egret employee, and we work as remote DBAs. And a lot of companies are using our services both in Russia and outside the country. We've got very massive DBA background on different projects. We are providing consulting services on PostgreSQL for those companies that do not need DBA services, but they need some, let's say, small audit or consultancy. We are doing this too. Since we've got a lot of experience, we've got different databases under the load, we've got something to share with you. That is why we are preparing reports for different conferences. What is interesting, we just tell you what is interesting for you, and also we arrange workshops. Sometimes at conferences you can arrange workshops. If there are any urgent topics, we can arrange a workshop. For example, last year it was an online training that I did myself. So this is what we are doing and what we can tell you about. My topic is tracking poor queries. And this topic is more for backend developers. So people could understand when something goes wrong between backend and database, so they don't go too deep into PostgreSQL kernel. This topic will allow you to understand how to fix your problems easier. Talking about poor queries, here comes the question: what is poor query for you? Okay, this is the classical answer: long query. And what about a forgotten piece of code that is just bombarding database and doesn't get you any result? Is it good or bad? I got an example. My customer asked me to deal with one query. They say, well, take a look, but it took us a while, and then the output traffic was too high. The traffic interfaces couldn't withstand it, and the problem was that it was just a legacy code that didn't do anything, and they just disabled this code, and half of output traffic just disappeared. The CPU, the memory load went down, and everything went well. So poor queries can be different, not always long queries. It could be queries that goes along with the sequential read. So that's why if we continue discussing this, so potentially long queries. So we have with recursive, and this is one of my examples of those ridiculous queries that ORM are executing when they are just going through different columns and they put it on backend. So some people think this is a poor query, but if you execute this query once an hour, that's okay. It will not get you any high load. You cannot consider this as a poor query. And what about this query? What do you think? Is it a bad query or good query? Let us assume that in this database we've got information on 100 planets and we have 300 records. If this is a query from the web form where a person just fills out some information, and every time you hit a drop-down list and we got a query to database, so we are just hitting the same references. We are hitting this reference with a small but frequent queries, and they are numerous, and they require CPU time, they require drive resources and network resources as well. So this is a bad query too, if they are numerous and they are being executed every time, especially when it can be cached, and no matter whether there are indexes or not. Another good example. Just classic. So, poor queries can be defined by the amount of resources allocated to the database, and the amount of resources consists of CPU time, network load, and drive resources consumed by queries. And most of the time it's not slow queries, it's our routine queries, fast and frequent. And I'm going to tell you how we are tracking these poor queries, and then how we deal with them. How to deal with them is just another topic. I will tell you only about how to find them and what kind of tools you can use for it. So here let's say we are hitting reference with 60K per second. It's not good. For backend, we need to cache this kind of operation, because reference is the information that doesn't change a lot. And it's not difficult just to recache reference information if it is changed. Everything depends on how frequently you modify your reference. And here are resources that we use: CPU usage, CPU time, and this is the image from our production database. This is NVMe drives, quite good, quite decent and powerful drives. But you can do it even if you're a good DBA. And what kind of tools can we use? Sometimes when our customers ask us to deal with their database problems, we're using PGBadger. This is a very decent tool. I like it, but we need Postgres log in order to use it properly. And last time I faced this situation, I had to purposely configure this PG Badger for logs. It's not very convenient sometimes. You just have to deal with that. You have to have a special log for PG Badger. Another moment, the more logs we have, the more load there will be for drives. So there are some dirty logs, and in order to work with PGBadger, we have to log all queries. In order to log all queries, well, that's quite a challenging task, especially when there is a 50K transactions per second load. Another drawback is that we need some time to parse this log, so PGBadger could build their reports. The reports are beautiful, they are nice, but it will require some time. And another example that tells you that it is very difficult to do and it is very expensive. If we have a small query with 100 bytes, but this is a rare case. In most cases, queries are longer, several kilobytes. Well, we get 100 bytes, 50K queries per second, and 1/3 of terabytes of logs per day. But this is just an ephemeric example, because most of times queries are bigger in size. Sometimes logs can be terabytes in size. Anyone watching these logs? You do? Well, you're a perv. Well, this is a problem. PGBadger is cool, but within some limitations. So as a custom tool, it's not okay. So talking about PGBadger advantages, you can use, if you log all queries, it will collect information on all queries. The reports are nice and beautiful. Also in logs you can find information about parameters. And also we will be able to work on this information in an efficient way, but this will require time and you will have to wait. But when you have to fix the problem right here, right now, you have to do something else. And just visually, PGBadger is very beautiful. I saw PGBadger reports, they just improved them, everything is nice and pretty. And everything is readable and clear. That is why PGBadger is good, but we're not using this because it's absolutely helpless for us. Instead, we are using a different tool. So my report maybe is obvious for you, but we are using a very old tool, but some people don't know how to work with it. This is PGStat statements extension, which is a standard PostgreSQL extension. And in order to enable this, you have to write in PGConf file the corresponding library and to create an extension. And then you will start collecting all runtime information on all queries. and you will get a special system table with all PGStat statements. PGStat statements collect information on all queries. Depending on the configuration, some queries will disappear from the stats, and they will just remove the PGStat statements will remove queries that are not relevant for us. We don't have detailed information on each queries. We don't have parameters, so this is like faceless queries. So we will need this just to get a full list of queries. If we see that a query is not okay, we can go directly to it. The main feature of PGStat statements is that we can reset statements. So we collect some statistics, we form this report, and then we just restore the statistics. You can use it when we, for example, we deploy a piece of code and something went wrong. You can do it on the fly. We work for 5 minutes. We reset the stats. We work. We collect information on these 5 minutes, and by using this report, we can understand what ruins our life in the database. Some people ask about overhead. When you are using PGStat statements, it's from 2 to 5%. But everything depends on how you measure it. But I recommend you not to think about overhead, because if you are working with PGStat statements, it will give you more advantages than drawbacks. So don't care about overhead. The main feature is that the database tables can give us some stats on queries. Some people just watch at PGStat statements, and if you take a look at the table, the information maybe is not that clear, but still you can work on this. And let's talk about how we collect stats from PGStat statements in order to understand what queries are required for us.
У нас есть
We have open replica, and using this replica you can get this report, and you can use it. So I will go through it in detail. So that's our working report that we get from all the servers that we are supporting, that we are maintaining. The first line of this report, the total time that the database spent to process the queries. So 24 hours per core. So it can be more than 24 hours depending on how many cores you have in your database. The total queries that were registered by PGStat statement since the statistics was reset basically the last day, and the unique queries from this number. So 41 million of queries and 1,000 unique queries. That's just a general information, the situation about the databases, just for the understanding about how many queries were made. And since we have a lot of servers, we need to understand right away, so which version we used to make the report and which version Postgres was used to collect this report. It's useful because different versions of Postgres, they have different optimization. The higher the major is, the more ways we can use to tune the query. It just allows us to get the information, what tools we could use to optimize the query. This line here is just for the understanding a lot of servers, so each server, how it is configured in the way it uses PGStat statements. And what is the minimal length of the query that gets into log, so that we could understand, will we be able to find this query later in the log, or we will need to reset to make the logging of all the queries to find it. And then we look at the position, the queries that we are interested in. And it has about 40 positions in the report, and on top there are the most heavy loading, the queries that are becoming the biggest, heaviest workload for the database. And the good thing about this report is that you don't need to look for the worst query. Here it is, the very first line, the next bad query, the second position, and so on and so forth. And what can we see from this report? That's a standard SQL query based on PG stat statement. The time that was spent to run this, up there it said 15 hours. This query took 10 hours of the database time to be fulfilled. So 2/3 of resources was allocated to this particular query. And then it's a big workload for a CPU, so not just the disk. So mainly this query goes to memory. So all the tables, all the indexes are in the memory, and then it's read from the memory. And then it takes 69% of the CPU from the total CPU time that the database is using, and that's not 100% of all the resources of the database. Oh, the server, that's the 100% from what does database is. So from 100% is what database is using. The number of calls of this query, so that we could understand how bad is it, is just 1 million in this particular case, so it's not that frequent. So if we compare it to 40 million of the total amount, and average time, it is quite fast. But if we look at the resources, then we see that considering all, then it's among the top queries that makes the database work the hardest. And we can see that it takes up a lot of the CPU time. Most likely it doesn't have some index, and that's why it creates so many problems. But it's just a detail. We need to look at this particular query, but now we can see what query we need to work with. And to facilitate the search, there is information which user and which database this query was made, so that we could go into logs for some examples. And the number of lines it gives back, it returns the number of lines equals number of queries. It means that each query returns just one line. It might seem that if you look at it separately, it doesn't really attract that much, draws that much attention, but if we take all these specifications combined, that's the worst query in the database. And the numbers themselves from the actual database and the queries have changed, obviously, so that not to display the information of my clients, I just put here just a random query from the top of my head that would just at least somehow correspond to this situation. At this position, you can see the query, where we should look for this query in the logs, because we need to know how it looks like, this particular query. If it had some parameters, so where you see parameters, it would have question marks, and we would have to go to the logs and look for some example of this query, so that we could use parameters, so that we could run it, and then we could see the exploits and then optimize it. The main thing that we have the candidate now, and then we go just position by position. There is some queries that generate a lot of the disk activity when so it reads a lot of data. But the main idea, the main thing here, that in this report, just in the right order from top to bottom, we have the worst queries. They can be all kinds of queries. It doesn't have to be slow queries. It could be short, small queries. And when do we need to stop optimizing our queries? How to choose this moment? In this report, there is a special line that is called user. So in our report, we have a limited amount of queries, only 40 lines, I think, and the rest of the workload that doesn't have any time to extend. So it just goes in one line, and it helps you to understand to get the information about the rest of the query that we are not that much interested in. And for you, it could be a red flag when we optimize the work of queries in the database. So it could be a red flag to stop the first level of the optimization. That all the queries above user are bad. Under it, so they're also bad, but you can deal with them sometime later. If your first position is giving you this other, so you can just sleep calmly, but you have to deal with the queries above the other line, and you need to do something about those so that their workload wasn't so heavy on your system, on your resources. That's our main tool that is working anywhere. If you try hard, if you really work on monitoring hard, then you can get the real-time stats for each query. And I will show it sometime later. So yesterday I had a great fun at parties, so I'm a little bit lost in the order of my slides here. So apart from getting the general picture about which queries are bad and which queries we need to work with, we can also, since we have a lot of servers, and these reports, they are sent by mail and from other sources, we can add some additional checks. For example, if we didn't get a report from one of the server, it meant that server went down and no one knows about it. It happens actually often when we have the main database that we are monitoring, and there are some additional databases that working with some small things and no one thinks about them until someone refers to this server. And quite often servers like that could die, and for weeks it would go unnoticed. But we should really look after these smaller servers, and it really helps. If you don't delete these reports, if you collect them, if you gather them every day, then you can analyze these reports to see how did the situation change in your database, and you will be able to see what are the new queries in your database that really works your system. Usually they appear after the deploy, but sometimes there is a situation that, for example, your data distribution changed, and the query that used to work good will be at the top position all of a sudden. And after collecting the reports for a certain period of time, for a week, for a month, you will be able to see it real easy and quick. And also when you analyze, you will be able to understand how often this query is run, and you will see how does your backend work your database, so how often does it refer to this particular database, and some other things regarding CPU time, regarding the disks. If you analyze this chain of these reports, you will be able to see all that. We are also doing that, but that's more of an internal stuff. If we look at the picture, then at these graphs you could see the PG stat statements, actual graphs regarding one particular query. And we can see here that the average query time, we can see the resources that it used. You do it manually, your own monitoring. We have some support guys who created their own monitoring tool, and there is some guys from Ekmeter. These are the pictures actually of their monitoring tool, so it works just out of the box. So these are just 1 minute report that you can visualize like that, and it looks just beautiful. And this picture is these pictures you can see after we optimize the query, how much it helped to the database to reduce the workload, so how much was the influence and the resource workload was reduced, so you can make it really look beautiful. And I was talking about it being open access, so here is the information where you can find it. We have this PG utils where we upload all the useful tools, all the useful scripts for all the things that we do with the database. So these reports, you can find it there, and some useful scripts to find indexes, databases that are too big, the indexes that you are not using. So there are descriptions. So be my guest, please use it, and the most detailed report, what I've just shown you, you can find this report going by this URL. It's just full URL for you to use. And there is another open source. There is a database compactor, a special tool that would just clean up the database. There are a number of tools that allow you to hide with the bloat. Number of these tools that one of them we created by ourselves, so it doesn't really rape your disk, and it works neatly, but it works slowly. But in certain cases, when there is not much space at the disk, or when you can't overload your database, so that's the tool to use. Yeah, so link went to the bottom of the page, so probably you don't see, but you will find it there, or repository. And then now the special bonus, the special added bonus, because I didn't know if I would have any time for that. So bonus about the bad queries. There is a mistaken view that it could be a bad query in the database, but the problem is the long transaction. That's among developers that the most common mistake that their database suffers from the bad queries, but actually they have this long transaction there, in the average query time are milliseconds, and the transaction you can see they're 10 minutes, 15 minutes, and the queries are milliseconds. And then if we look at the session state, then there are not so many active sessions, but we see the gray sessions are sessions that are idle, not doing anything, and the yellow are that the most of the developers are doing. They like to open the connection to a database to change something, and then they do not commit their transaction, and their transaction is still there, and then they say that's a query problem. That's not a query problem, that's a transaction problem, and you must understand it, and you must separate the two. And when you try to optimize your database administration, first of all, take a look at this picture, and then start looking at the reports and at the queries. So you mustn't have any yellow. Yellow could only be for such languages as Ruby, Python, interpreters that don't have multi-flow systems, and sometimes they get stuck at the idle transactions, but one or two sessions, but not hundreds of them. Have 500 sessions, and yellow is half of them, 200, 300 in idle transactions. So database is not going to feel well with that. And that's it. That's all that I had to tell you. Well, I guess that how party affected me. So talking so fast. So on one hand, I was a little bit of a Captain Obvious here, but on the other hand, practice shows, experience shows, when you are showing this thing to people, it's an interesting information to have. And small commercial break. Our company is organizing PG Day. We haven't been doing it for some time, and now in July it's going to happen in St. Petersburg again after a small break. So if you're interested, that the second large Russian conference on Postgres, I have learned about it after I knew about PGConf, but I went there even before I was the data egret employee, and I really liked it. So it's really cordial and heartfelt conference, so I really recommend you go there and to listen to the speaker there, and speakers are different that conference. So that's all I wanted to tell you. If there are any questions, please ask your questions. Thank you, Andrey. We have a lot of time for questions, so please. And I apologize, so I guess I was too quick to tell everything, to spell everything I had. Andrey, the question I have, you were talking about the reports, but let's imagine the situation when the client writes something into a chat room, everything exploded, we need to find the solution right here and right now, the reason. How are you going to look for the bad queries right here and right now without any reports to work with, without configuring the reports? Thank you. You are a bad person, Alexei. So it's a tricky question. Well, if there is some crash that happens at the database, first of all, we go to pgstat activity, because pgstat activity will show what the current situation, real-time situation with the database. At the same time, in the next tab, we open a top to see what's going on with the server resources, and then we go from there. Usually, if it's some emergency and we need to handle it immediately means that either a client has a many-hour report or idle transaction, many-hour idle transaction, and it made some changes, it got some log, and then this log gathered a whole queue from other queries. That's the classical typical thing that happens from our experience. And there is no bad query here. That's the most common case that happens when we work with the database. When the database is under heavy workload, then what do we have? Well, when it's under heavy workload, then we start collecting these smaller reports, looking at the queries that are overloading the database. So yes, Act Matter, those who have it, then we use it too. Act Matter, a lot of our clients, they have it installed as a monitoring tool, and there is a tab where you can see which queries are in the top for this particular moment of time. I showed you pictures for one query, but it contains information there is a separate graph of the top queries on CPU, on the disk space, disk resource, and so on and so forth. So you need monitoring to resolve it quickly. If you don't have monitoring, it's impossible to resolve it quickly. You will have to dig deep, and maybe you will not be able to resolve it quickly. Maybe a server will fail, will go down because of that. But if it's not for idle transaction, if there is some query that collected the tail because of the lock, then you can only solve it, you can only find it using a monitoring tool. Any other questions? Questions about monitoring? Can you share the ActMat link? ActMatter link? ActMatter.io? Well, you can find it online, just Google it. Usually they have stands at the conference. They didn't come this year. They've been coming for 5 years. Somehow they didn't come this year. But oakmeter.io, and there they have this horrible coloring of their page. You won't miss it. Any other questions? I've got a question. I'm here. I see you. We automated, but not for open source, so we didn't have it for open source. The question is the stats for the input-output. You showed it there. I guess it's a different extension that is collecting and not stat statements. Please, could you hold the mic closer to the mouth? Stats on input-output. It is collected not by PGStat statements, but by some other extension. No, that's PGStat statement that collects it. Everything that is on the graphs or what? No, in your report. Oh no, that's all based on PGStat statements. You need to install PGStat statement, create an extension, and then you just start a query, and then you will get information. Don't forget to reset the stats from time to time. It's very important, because if you will collect it for a year, then you might have some ancient queries that will not be able to collect from there, and they will ruin the picture then. So you need to reset it weekly, annual, daily, so you can do it hourly even. You can create these hourly reports.
Hello, and thank you for your talk. It was great. Yesterday it was another very interesting report on PG Profiler. Have you ever used it? If you have, what do you think about it? Well, so I've got some background on Oracle databases, and all these features came from Oracle. And when I started to work with Postgres, I really missed them. But then I just got used to Postgres tools, and I don't need any profilers anymore. However, in Oracle, I really like them. In our experience, we are not using profilers because we don't need just. Here we get another tool to do the same and to do it correctly. Otherwise, people will not come to us. So I've got a question, just like a follow-up. Such extensions like pg equals stats and pg equals cache, have you used it and what can you tell us about it? So our gentleman starter pack of extensions that we're using is pgstate statements for sure, check to collect information from databases, pgrepack, and that's it. The rest is what our customers need. We're not using any more extensions because this pack is enough for us. It is enough to fix all frequent problems. Anything above? Sometimes you can use something specific when you have unexpected or unusual Postgres behavior. Sometimes it is connected to a kind of bug, and we can install anything that will help just to capture this problem. But this is a rare case because Postgres is a stable database and it doesn't have a lot of bugs. A small question. Auto-explain. Have you ever worked with auto-explain? Auto-explain? No need actually. To be honest, DBA work is, so we get a database. If everything is bad, we work very intensively to reconfigure it, to fix some errors, to optimize queries, and the rest is quite stable. If we've got one poor query, well, we will just handle it. We see it in a report, and we just get it, we just catch it. So we don't need any extra tools. Any more questions? In PGStat statements, you see only high-level queries or any queries from the code too. If you call for the store procedure, you will have to go directly to it. Any more questions? If you have any more questions, just find me at the conference. Maybe you've got a tricky question for yourself. Okay, looks like there are no more questions, so let's give a round of applause to our speaker and say thank you.